Hey there, guys. This is John O'Connor, and welcome to Code Your Face Off Live, a weekly show where we go over Android, front end, all kinds of cool, fun development stuff. Sorry for starting the stream a little late today. I was trying out a new piece of software and it didn't work, so we've got a new link here. I think that means a lot of you will be watching this recorded, which is fine, but the few that are out there live, hi, welcome. So today we are going to continue working on our Astronomy Picture of the Day app. We're going to start adding some more stuff to this thing here. So today's episode, we're going to finish up our discussion of async tasks and threads. Last week I showed you a few ways that you can do separate threads in an application. I missed one actually, a thing called the executor. And so what I'm going to do is walk you guys through how the executor works. It's very similar to a handler, so you should be able to get a good feel for it if you've used handlers and you saw how we did handlers last time. Then we're also going to talk a little bit about how to do data access object as a pattern, as a design pattern. So this is a concept that is designed to help you get data from certain sources and save them off into another one. And so we'll talk about how we could save the data that we're getting from the Astronomy Picture of the Day site. And then finally, we're going to wrap up with Android fragments and activities. We're going to go ahead and refactor our app a little bit by putting the pieces into a fragment so that we can kind of see how fragments work, how to send data between fragments, and the difference between some of the different ways you can interact with fragments. For example, adding a fragment versus replacing a fragment. So that's going to be what we're looking at today and what we're talking about today. So we'll go ahead and get started. I'm going to pull up Android Studio, and I'll share the stream over here with you guys right now, and we'll get that going. So let's see here. I'm going to pull up the Astronomy Picture of the Day app. If you haven't seen the last few episodes, you can get the source code from the description of this video. You can see in there are tags for each episode. So if you want to start at the beginning of an episode, you can go to the GitHub repository and actually back yourself out to one of the previous episodes and work along with me as well. So I'm going to save those all inside of the version control system. Let me go ahead and get us switched on over. We'll go ahead and do our Android Studio. Okay. So there we are, Android Studio. I went ahead and updated this guy relatively recently, so hopefully we'll be able to get some rendering going on here. It looks like maybe not. I'm just going to check in with Kevin and Wayne and see. Are you guys in there, Kevin and Wayne? Can you guys see me at all? Let's see. I'm just going to make sure we get some interaction in here. So anyway, we're going to go ahead and jump right into this thing. So the first thing I want to do is talk a little bit about, the last thing that we had was the executor, right? So the executor is a library that allows you to run threads, things in a separate thread, right? You guys, nope. Good, text is nice and clear. Okay, Wayne, for some reason, Kevin's able to see it. So, all right, well, I'll go ahead and let that one go. And hopefully, Wayne, you'll be able to jump in here in a minute. So last week, I showed you a few different ways of doing async tasks, right? The first one was, or rather, by doing things in a separate thread. The first was by using the thread class itself, which I have here down, commented out somewhere in here. Then I showed you how to use an Android handler, which is a way of executing runnables kind of separately. And then finally, I showed you how to use an async task, which is another library that Android provides, or another class that Android provides to do background tasks. Now, the last thing we want to use is an executor, or the last thing that we have at our disposal is an executor. An executor is very similar to a handler in the sense that it is something that's designed purely just to run separate tasks, right? So let me go ahead and pull up the documentation. I always recommend highly that you jump over into the documentation for any of the Android libraries that you're using. It's always a good practice to have that kind of sitting there in the background. So I'm going to go ahead and pull up that documentation for it right now, and I'll switch my screen so you guys can see this thing here. Been doing some other editing in the morning here, so I'm going to switch it over right now. There we go. So I'm going to go ahead and switch to another screen that I have shared here. We're going to go ahead and pull up the Google Chrome screen. You guys can see it right now. So I'll just take 1 second here to get it. Cool. Google Chrome. And let's go ahead and share this new tab we've got here. And we're going to go to the Android Executor. We're just going to take a look really quickly at this documentation. And you want to get used to using the documentation as much as possible, right? You really do want to use the docs as much as you can, because they're there for a reason. You know, they're there to help you work through this stuff. So what is the Executor exactly? The Executor is actually a Java class. So when you have a handler is actually an Android construct. It's available in Android. They use handlers for other things, but the main thing they use them in Android is to run separate threads. An executor is actually Java's sort of version of that, right? So that's basically what you're looking at. It's essentially a Java version of a task executor, right? And let me see. We can call, so let's go ahead and implement a very simple executor that basically does what our async task already did before, right? And you can see this kind of almost resembles an async task, right? You have this execute method that takes a runnable, and then you just run the runnable pretty much. And you can decide how you want that to work, right? You get to control how this runnable task actually gets executed, which is kind of interesting. Let's go ahead and so in essence, it's a way of you building your own handler, I guess would be the right way to put it, you know. So let's go ahead and create just this simple direct executor, right? This thing, this actually would run the task in a runnable directly without running it in a separate thread. So let's kind of play with that a little bit here. I'm going to go ahead and create, instead of this downloader task, let's create an executor. So we're going to say executor, let's say private class, we'll call this direct. We'll just do a copy of what they have, executor. Extends, I think that's an implements actually, let me double check. Executor is an interface, right? So it is an interface, implements executor. And the reason I didn't go over this last time is it's kind of, you know, kind of an uncommonly used thing. So let's see here. Most of the time you're going to want to use the utilities built in here, but just in case you want to have some custom running of tasks here, in case you want to kind of specify how a task can be run, you can actually implement your own. It takes this runnable, and we're just going to call, oh, Share Studio, my bad, thank you. Yep, let me go ahead and switch back over to the Android Studio there. That is why I love having you on here, Kevin, because I can you tell me what I'm missing stuff. It's perfect. Here we go, we're back into Android Studio. And what I did, I'll go ahead and just restart this really quickly. So what we want to do is we want to create an executor that's going to execute tasks. So let's go ahead and do private class direct executor. Executor extends implements executor. And this comes from the Java util concurrent class. That's how I knew that this was a Java construct and not an Android construct, because the package name kind of tells you where it comes from. Using our Alt-Enter trick here to give us a little hint as to what that red line means, we just have to implement the methods. And the method that we're going to implement here is the execute method. You can see execute just takes a runnable in here, and all we have to do is do something with the runnable. Something as simple as runnable.run. Calling the run method on that runnable is perfectly fine. So we can do that. And the thing is, when you do the runnable and you run it directly, it means that this runnable here is not going to be run in a separate thread. You're like, what? Wait a second, why would you even bother to do that? It actually, depending on the context, you may not want it to run in a separate thread, right? Part of the run on UI call that we made up here last week, and if you recall, run on UI allows us to take a separate thread and then still update the UI, because you can't update the UI normally from a separate thread. The run on UI thread method allows us to do that. I'll show you, it's right here. So this run on UI thread method is actually a very custom example of an executor. This under the hood is an executor method. So we're just going to create something like that, and all this is going to do is run this runnable. Now, the problem with running this, with doing this here, is it's not going to put it in a separate thread. So we don't want to do anything too major in this task. What I'm going to do is, instead of doing anything, anything that's going to hurt this program, I'm just going to create a runnable that doesn't do much. That just prints out, hello world, right? So we'll create a new executor, and actually we want to create a direct executor, right? Our subclass here. exec equals new direct executor. And we'll go ahead and pass in a new, we'll go ahead and say exec.execute, and we'll create a new runnable. And remember, runnables are just things that can be run. So we'll go ahead and say alt enter here. And here's our little run method. And inside the run method, I don't really want to do much here. I want it to be pretty simple. So I'm going to say log.d, we'll give it the tag name, and then we'll say hello world from the direct executor. Right, there we go. Kind of a simple little program here. Let me pop open our little Genymotion. Do I not have one? I guess I don't. I'll pop open a Genymotion emulator just so you can kind of play with this here. And what I'll do is I'll go ahead and share my full screen after this so you guys can see the emulator as well as the logs here. Let me go ahead and share this full screen. Get rid of that. There we go. Continue. So what we're going to do then is just run this executor so you can see that it gets executed when we call this main activity. And it's just going to get executed directly because we're using a direct executor. Now while we're at it, while I'm waiting for this thing to come up, I'm also going to create a separate kind of executor. This is still the same sort of thing. It's going to have the same interface where you just call execute and pass it a runnable. But now I'm going to have it actually do that in a separate thread. And this is going to be more like what a handler looks like. If you were to pop up the source code for Android's handler, it's going to look something like this. So we'll call it maybe a thread executor. How about that? Implements executor. And then we'll create this new class here. And let's go ahead and give it some methods. We execute here. And again, just Alt-Enter will give me that little menu that you saw kind of flitter by. And then let's create a new thread. How about that? Let's say we'll create a new thread out of this runnable. New thread, runnable, start. So this thing is going to automatically start our runnable in a brand new thread, right? And that's it. That's all this thread executor is going to do. So we can see the direct executor running our really simple code here. We'll also create a thread executor just to see how running it in a separate thread might look. Separate exec equals new thread executor. And let's do something in here, separate exec dot execute runnable. And you can put anything inside of this runnable that would make sense to put it in a separate thread. So this one doesn't, we don't have the same limitation of trying to, trying to keep it small here. We could actually do something pretty advanced. We could actually do this execute method we have in our downloader task. I'm going to go ahead and actually take that and put it inside of our separate thread here so you can see it in actions. Yeah, I'm going to grab that guy, I'm going to copy it. And actually, yeah, I'll go ahead and copy it, and then we're going to paste it right up inside of that runnable right up here. So this separate thread exec, it can actually have a full range of different options here. Let me go ahead and get rid of string 0. We don't need that. And we'll get rid of the return null because we don't need that. And that's it. That's all we need here to turn this into an actual separate runnable entirely. And I'll go ahead and just disable my async task that we were using to do this for now, so you can see that it all works. So let's get rid of this task.execute, and I'm going to get rid of this downloader task. Let's go ahead and try to run this guy and see what all of that resulted in, right? Let's play with this a little bit. We're waiting for Gradle to do its magic here. So summing this all up, we essentially created a new class that allows us to execute runnables. That's basically all an executor is doing, is a class to execute runnables. And you get to decide how the execution process happens. A handler, on the other hand, does this execution for you under the hood. So it's basically an implementation of an executor. And let's see how this guy pops up here. So we're going to wait for our Start a New Picture of the Day app to show up. Oh, that's kind of funny. It went in really small up there. And you can see right here on the bottom, here's our astronomy picture of the day. So we know that our executor actually worked, right? We got our code in here, and you remember that this code does not exist anywhere else, right? This is not inside of, we're not running our async task. We're not running anything else like that. So this was actually what was going on in the main thread. So let's go ahead and do a log tag, and we'll say, or this was what's happening in this executor. Say this is happening in a, right, let's try that. Just so we can see that a log actually happened. I could also do a breakpoint right here, by the way. If you don't know about breakpoints, they're kind of cool. We can click in this gutter right next to our where our app, our code window is, and you'll get these little red buttons. These represent a breakpoint. This is a suspension part of your program. So what will happen is if you debug it and the app gets to this line, it's going to freeze everything. It's going to stop the app from running, and it's going to pull this up and let you inspect all the variables that come in. Let's do a couple of these. I want to show you what this looks like, because this is one of the most handy tools you're going to ever find in an IDE, in a debugger like this. Breakpoints, you're going to use them all the time, especially in a production system. So let me go ahead and try. You have to run it with the debug button right up on top. So you have on the left side, you have the play button, and on the right side, you have this little bug. In order for the breakpoints to work, you have to run it in debug mode, which is that little bug right there. So let's pop this up and see what it does. All right, we're going to wait for the program to run here. Looks like it's coming up now. And then the world should stop momentarily. It didn't. I wonder why. What did I do wrong? Oh, that's what you get for trying to demonstrate it. Let me see here. Yeah, you know what? It didn't end up actually updating that at all, did it? I wonder if maybe we're doing something somewhere else here. All right, well, I didn't get the debug to stop. That happens occasionally. Sometimes the debugger just doesn't settle properly, but that's all right. You know what? We'll deal with it. In any case, you usually can do this. You can have this little debugger actually suspend the entire application and wait for you to do something, essentially. Maybe I have. No, that's all right. We're not too worried about it. I'll have to demonstrate that feature at another time. But that, in any case, that's the executor. That's how you do an executor and do separate task execution with an executor. So somebody had asked, I went through it last week, the thread, handler, runnables, and this was the last piece to that. Formula is the executor. So anyway, that's what we've got here. I'm going to go ahead and comment these guys out. So I'm still going to leave them inside of the code, but I'm going to comment them out because we don't really need these anymore. You can still see how it's all done, but we're going to comment those out. Kind of a handy pro tip, by the way, in Android Studio is you can highlight multiple lines of code and hit on a Mac, it's command and then a slash like you would do for a comment here. If you do command slash, and on Windows it's control slash, you can uncomment and comment out multiple chunks. So that's what I did here is I highlighted it and then I just hit command slash or control slash. And that's the slash next to the question mark. That will allow you to uncomment and comment out huge chunks of your code, which, if you're a developer like me, you have to do it because we screwed up a lot. So I end up having to comment out tons of code. Let me get rid of these guys because I don't really care to have them in there. And I'm going to go ahead and just rerun this async task. So I'm going to uncomment out the async task that actually was doing most of the work last time. Run it again just to make sure. We'll do a little parity check to make sure everything's all right. And then we will move on into the idea of data access and data access objects. All right, let me just double check this to make sure everything's all right. Come up here in a second. And voila, okay. And voila, we're good. Let's see if our details. Yeah, that works okay. Perfect. So we're good. All right, so next section. We're going to talk about data access objects and accessing data inside of your app. So a lot of my students have been working with data access lately, and they've been kind of wondering, what does data access mean? Like, how do we access multiple pieces of data at the same time? And how do we kind of collect these sources together? So I'm going to stop that and talk to you for a minute. So yeah, the idea of I guess most apps is they really are just presenting data that you've already seen, right? That's the same thing with our Astronomy Picture of the Day app now. It's presenting data from the astronomy, from the NASA.gov website, and it's just giving us a nice form for it in a mobile app. Your app will often have multiple different data sources that it's pulling in from. An example would be if you were doing a mashup, right? If you were saying, I want to take the Yelp API and the Google Maps API, and I want to show the Yelp data inside of Google Maps, which is kind of a common case. You can do that by creating these multiple data sources, pulling them in, collecting them all together, sort of making them mash together. And a lot of people kind of get stuck on that. They're like, how do I even start? What's the idea behind that? How do I do it? So I'm just going to give you a pattern that you can use called the data access object pattern that'll allow you to kind of abstract access to your data. And that'll allow you to create these interfaces that work really well for hiding the details of where you got your data. And that's the whole point of it, is to say, it doesn't matter where I got the data from as long as I know it's coming in and I can make this call and it'll work. So we're going to talk a little bit about the data access object pattern. Let me switch you back over to Android Studio. Actually, what I'd love to do is a little sketch of this. Maybe what I'll do is I'll pull up Keynote and just do a little sketch. I think that's what I'll do. I'll show you guys what the thought process is behind this pattern altogether. And I'll share this with you right now. We got Keynote. All right. And we're good. Let me just go ahead and get rid of a couple of these. And I'm just going to do some quick shapes, right? So this is called the data access object design pattern. And you'll see it also written as DAO, right? You'll see me use that DAO term quite often. I'll make this a little bigger so you guys can see it. There we go. Okay, so what is the data access object pattern, right? What does that mean? It's a way of getting data from an external source and making it accessible in your app in terms that your app cares about. So for example, let's say we're creating an application that displays images from multiple social networks. This is actually a real project at one of the online boot camps. So let's say that we have a Facebook, a Twitter, and Instagram application, right? So what we want to do is we want to take all of the data from Facebook, Twitter, and Instagram, and we want to combine it all together into one app, right? We want to turn it into one feed that our app can then use. So that's going to be the basic idea. That's going to be the example that we're using here. And it doesn't matter that it's multiple data sources. You can do this with just one data source, and it's not a big deal. That's what we're going to do with our astronomy app. But the same pattern can still apply, right? We want to bring all these together. They're all in different formats. This might be a red square. This might be a green square. This might be a blue square kind of thing. They're all different, but we want them to come in and normalize into this purple square, which we can then display, right? This goes into our mobile app. So all this data goes into here, which I'll just give it some kind of that's our mobile app, right? There we go. Make it look like a phone. And there. Okay, so what we want to do is normalize this data into a single common format. So how do we do that, right? How do we take the Facebook JSON, the Instagram JSON data, and then the Twitter JSON data? How do we change these around? How do we make them all into one format? And the answer is by using these data access objects. So here's the idea. We start out here, actually, in the beginning. What do we want to represent on our mobile app? What are the pieces, right? Do we want our app to be do we want it to display, for example, an image and a caption, right? We can do that. Let's do an image and a caption. So those are going to be the two pieces of information that we care about, image and a caption. Now, in Facebook, they might be stored as a picture and maybe text, right? On Twitter, they might call it a picture and a caption, or a photo and a caption. Maybe photo and text, we'll go with that because I'm lazy. And then here we'll call it a photo and a caption. Right? These all name them different things. They're all different names for essentially the same idea in our app. So what we want to do is we want to say we're going to take these ideas and we're going to turn them into, I'll give this one a name as well. This is our photo and our caption. So we're going to use those two terms in our app to represent those two ideas. And that's what we're going to display maybe in a list or something like that. So what we want to do is take this main object model and create a data model for this, right? So we're going to have an object in here. This will be, a class image. And inside of that image, we'll have a photo and a caption. I'll go ahead and left align and give it a nice, let's see, console. We'll give it a nice little console looking kind of thing, right? So that's what we want our data member in here to have. We want our image to have a photo and a caption. And we want to say no matter what they store it in as Facebook, Instagram, or Twitter, we want to eventually turn it into this single image, photo or caption. This thing in the data access object pattern, this model in the middle, is called a transfer object. It's basically the language that the rest of your app speaks. The rest of your app doesn't care where the picture came from or where the text came from. It just wants to know that there's a photo and a caption and I can display it everywhere. So this guy right in here, this concept, this model that's going to be used everywhere is called the transfer object, right? So we're going to take this code right here. This is the code that comes from Facebook and Twitter and Instagram. And we're going to create a little translation layer, right? So we're going to create this layer inside of our app. And it's going to take in data from one of these sources, and it's going to output transfer object for our application. So inside of this goes, inside of this goes data, outside of this goes, oh, good Lord. I got to get one of you guys in here to help me with this one day, just because I fumble with it. There we go. So we got this one, this one, this one. So what these are going to do is these are going to take in data and they're going to output a transfer object that the rest of your app can use. And once you have it in this transfer object format, now everything can talk to it. Everything, understands this transfer object format. And we're just going to do another little copy here so you can see kind of how that flows, right? So this little piece in the middle, what is this? This is this right here. This section is what we would call our data access object. This is what's going to go out to the internet. It's going to get the data from Facebook, Instagram, or Twitter, and it's going to return it to us and translate it into a transfer object, right? Let's go ahead and do that. We're going to reverse this guy a little bit, put him down and over, because that's what it's really doing. It's going out and it's fetching the data and it's converting it into a format that we care about, right? I'll give this a non-used color so far. I guess I'll just do, nope, what can I do here? Gray, blue, green, yellow, that'll work. Yellow will work, right? This is our data access object layer. We'll call this a DAO, right? And you'll notice that we have one DAO for every data source. So we have one for Facebook, one for Twitter, one for Instagram, because they're coming in different formats. The DAO actually outputs it into a single, I should just point it right down here because this is really what it's doing. It's turning it into a single transfer object. This is all the same format when it comes out. So these all end up translating it from one format to another. But we need one DAO, oopsies. We need one DAO for every data source that we want to use. And what's nice about this pattern is if we want to add more data sources, let's say we wanted to add another social network, something that became popular. I don't know, let's say MySpace became popular again, right? Let's say we did that. We can add another data source in here by just adding another DAO, and it'll still output to a transfer object. And as long as it outputs to this transfer object, your app doesn't care. As soon as it gets into this transfer object, this common data model, it can display everything. So the goal of the DAO is to do that translation. So what would that pattern look like, right? How would we do that? Well, we know we're going to need a transfer object. So let's go ahead and we're going we're going to create one of these right now. I'm going to go ahead and create an Android Studio, and I'm going to switch over to it right now. I'm going to switch over to Android Studio. I'm going to show you what this pattern looks like. So the first thing we want to do is we want to get the model down, right? Let's go ahead and create a new package in our Java application. Let's do a new package. I'm going to call it com.john.w.o'connor. You can call it whatever you want. .experiments.apod.models. I like to put them in these separate packages just to sort of separate the layers, right? So you know what the layers of the application are. And what is this model going to be? Well, this is going to be whatever our picture format is, right? Whatever we want to display in the app, we're going to create a data model to hold that. Let's see, what did I actually use in here? I guess I have an image, right? And I have a title. So let's create this new Java class, right? It's just a plain old Java class, what we call a POJO, plain old Java object, right? So we'll call this, how about we just, we call this, I don't know, science image. How about that, right? Because we'll say maybe we could get multiple science images from different websites. Maybe there's a Hubble Space Telescope feed in addition to the Astronomy Picture of the Day feed, right? So we've got this science image, and what's it going to contain? Well, let's see what we actually are pulling out of this application. We're going to distill what would we get? What would we need to display in order to make this actually work? We have a title and explanation. Those are kind of easy because those are just strings. So let's just do that. We'll start with a string title, a string explanation, right? And then we'll change that to description. We'll give that a better, give that something better. We have an image, and how did we do that image? I'm trying to remember now. I believe all we did was we used a drawable. Let me see what we're actually pulling in from the data feed, because that's what this data feed down here is going to do, right? So let's see. We've got this apod data.getString. We're just getting a URL, which is just another string. So let's go ahead and do a string image URL, and maybe a string subtitle. Maybe something has a subtitle. You know, we get to decide whatever we want to display in here, and then we get to choose what pieces of the Astronomy Picture of the Day app map over to our application, right? So let's go ahead, and we've got these in here. Let's make them private and we're going to use some proper encapsulation here. We're going to make these private, and then we're going to create some getters and setters and all that. We'll create a nice little, we'll create a constructor here. Science image, oops. Let's create a new constructor. That'll be our default. And let's just set all this stuff to null. Let's see, subtitles null. Description is null. And all we're doing here, remember, is just creating a data model that's going to represent our application going forward, right? This is just going to our application, sorry. It's going to represent the data in our app. This is all that anything else in our app is going to use is this science image. So when you're displaying something, you're displaying a science image, and that's it. And then we'll go ahead and create some getters and setters. Under the, I believe it's Tools menu. Where's that generate getters? There's a way for us to generate, under the code menu, I think it is. Let's see, generate, right? So it's code and then generate. And we'll say getters and setters. And we'll go ahead and create one for each of these guys, right? So let's go ahead and create, you'll highlight them like that and then you hit OK. And it's going to generate a get method and a set method for each of these. Now, proper encapsulation requires you to have these methods available that, that protect your data. So you make your data members all private, and then you create these methods called getters and setters that will allow you to access that data somehow. And even though we're just accessing it directly, it's still a good practice to do this because you never know when you might need to, limit access maybe to the image URL or something like that. So we'll go ahead and do that. And what we'll do is we'll actually let these things, for the setters, we're going to go ahead and have them return an instance of the class here. That way we can chain them together. This is kind of a fun little trick. I'll show you this. So rather than having it set void, we're going to have it return a science image. And then I'll show you why we do that in just a second here. Science image. This is so we can do some cool little method training, or method chaining, I should say. So we'll return this and return this. This is an instance of the science image. It's the current one that you're actually using and setting and all that stuff. return this, and return this at the end. Yeah. Right. And this is so we can do something like, new image dot set title dot set, description, that kind of stuff, right? So we've got this science image. This is our transfer object, right? This is our transfer object. It's the thing that's going to be used throughout the rest of our app. Now we're going to need some data access objects. And what is the data access object? Well, it serves two purposes, right? Two purposes. The first purpose is that the data access object retrieves data from a source. We're already doing that, right? We're actually doing that inside of the main activity. But we don't want to do that in the main activity anymore. Now we don't want our main activity to be responsible for getting data, because if we need to add a new data source, we're going to have to clutter up our main activity, and we don't want to do that. What we want to do is compartmentalize this so that each data access object controls where the data comes from. So let's go ahead and do that. And if you're used to this, I know some of the boot camps will call this a data source. Same kind of idea, right? A data source, data object, or data access object. We're going to use the same pattern for both in this case. So I'm going to go ahead and create a new package again. And now I'm going to call this one pom.johnwoconnor.experiments.apod.dao. And I'm going to just make this whole new package for data access objects, right? And the first one I'm going to do, I'm just going to do one for now. We're going to create the apod DAO, right? Data access object for astronomy picture of the day. And what's this going to look like, right? What's our data access object going to have in it? Well, it's going to have a few methods, right? Let's go ahead and create a nice little interface, because each of these DAOs, whenever you have a situation where you could have multiples, like astronomy picture of the day, we'd have one from Hubble, but they're all going to have the same methods on them in order for this to work. They're all going to have maybe a create method, right? We're not going to create anything. We really just want to retrieve is all we're going to do here. So let's just do that. We'll create a new interface here. Let's see. Those are all Android. You know what? I'll just give it a new class name here, and I'm going to call it interface. So I went to right-click, new, and then I selected interface under the kind section. And I'm just going to call this a DAO, IDAO. How about that? Interface DAO. Or how about interface science image DAO? That's just to give it kind of a separation here, because all of our science images are going to have the same kind of, same kind of access needs. And our iScience DAO is going to have just a method public, and it's going to send back a list of of science images, right? Retrieve. So we're just going to retrieve a list of science images from our data source, wherever that is. So it's going to return. You can already see here, this is our transfer object. So our DAO here is designed to return transfer objects, right? It's designed to return our science image, even though the data it's getting is not a science image. We're going to go ahead and import this list here, and we'll import a, I like the method body. Why? Oh yeah, I don't need the method body. This is an interface. We don't implement interfaces, do we? Interfaces are implemented somewhere else. So all of our iScience DAOs, they're just going to have this single method retrieve, and it's going to return a list of science images. Seems simple enough. So now we go back to our astronomy picture of the day data access object, and we're going to implement our iScience object DAO, iScience image DAO, right? Let me see here. Implements, haha. And we'll go ahead and implement these. Alt enter, same kind of deal. Where do we want this here? Oops. Alt enter, implement methods. And it's going to need us to implement a retrieve method, right? That's it. So what are we going to do inside this retrieve method? What are we going to do in here? Well, we're going to return a list of science images that have been downloaded from the astronomy picture of the day site. Let's go ahead and do that. So we've actually already done that, haven't we? We did that in the main activity. Let's just steal this background task right here, copy and paste this code into it. And it's going to be a little different because in our application here, in our main activity, we weren't just returning the data, right? We were actually setting all of these items on the UI as well. We were setting the, the image, and we were setting all this stuff. We were setting the visibility and loading and content. We don't want to do that anymore, right? We don't want to do that inside of our DAO. We just want to return pure data. So we're just going to grab this section of code here that that we used before to get the astronomy picture of the day data. This is a URL that just connects to the URL, creates a URL connection, reads and downloads the JSON content, and then parses out this information from the JSON object that returned. So this little chunk of data, that's really doing like 99% of the work. So let's go ahead and copy that, and we're going to stick it right inside of the retrieve method of our DAO. Let's do that. We've pasted classes that are not accessible. Let's go ahead and import. This is telling me you need to auto import all this stuff. Sure, why not? Let's do that. Our APOD URL, that's going to have to go in here as well. And that makes sense, right? It's specific to the astronomy picture of the day app or the astronomy picture of the day data source. Completely makes sense that we would have to put the URL in there as well. So let's go to our main activity. Let's go ahead and grab our astronomy picture of the day URL. Let's just steal all of these, right? Because these all are actually part of our, these are all specific to our astronomy picture of the day app. This guy right here and these guys right here. Let's just steal those, bam. And it's gonna break our class, and that's okay. We're not worried about it yet, because these are gonna go right in here. Cool, so now our URL makes sense. We are gonna have to handle a couple of exceptions. You notice we had a try catch around that other one. Let's just do that. Let's go ahead and say, okay, how about add a try? Well, a couple of options here. We can do two things. We can either say that this retrieve method will throw some kind of error, and that's something that you're saying, I'm going to throw it up the chain and make another developer handle it, or we can handle it, right? Since in this case, our URL is handled by our library, it's inside of our APOD DAO, I'm going to surround it by a try catch instead of throwing it up the chain to the next person, right? That's something that I just made a design decision there. If somebody else uses this library, I don't want them to have to handle an error that was basically my fault. And we got another unhandled exception there. So we're going to go ahead and handle this one as well. I think that's good. I think that makes sense there. Okay, so we've got this APOD data. I'm going to comment these out, but I'm going to keep them because the image URL, the title, and the description, those should look familiar to you guys. Those are part of our data object, right? That's part of our transfer object. Our science image has an image URL, a description, and a title. That's what we want to actually get out of that. So we're going to pop back on over to our APOD DAO. And I'm just going to create, how about this, a brand new, this is going to be my return list, right? This is going to be what I actually return out of here. So I'm going to put a little guy up here. Let's see. Yeah, we'll do that. That's fine. And we're going to say this is our return list of science images. Return list equals new array list of science image. And that's it. We're going to make an empty list here. And I'm doing a list because if we had multiple images that we wanted to get from this source, if we don't make it a list, we can only get one at a time, which is kind of a pain. So in this case, it's our retrieve is only going to ever have one item in it. Our list is only going to have one item in it. But I want to leave it open for later. So I had to make that decision when I built the interface. Do I want this to support multiple images later on, or do I want to keep it one image at a time? I'm going to make it multiple images. So let's go ahead and create now. We've got this array list for returning stuff. Let's go ahead and return it at the end, right? There we go. We're going to return our return list. And this is a practice I use a lot. I'll define the return on the top, put the return on the bottom, give myself a bunch of space in the app, and then I'll just write the code that basically goes in between the two, right in between there. So, okay, cool. This goes out, comes back in with this data, and now we want to take it, we want to stick it inside of a science image. So we'll create a new science image, and we're going to go ahead and say image.set, and this is where our chaining is going to come in really handy. Set image URL, and we're going to say we want this image URL right here. So let's take that little snippet of code that we used to get the image URL. We're going to stick that there, and we'll say dot set description or set title. Dot set Oh, I need the extra closing parenthesis there. Yeah. Set title. And we'll say this little snippet right here that gets the title, we'll just drop it in like that. And then we'll say dot set description. And we'll go ahead and drop this little guy in there. There we go. All right, and we've got a new science image, right? Now the last thing we have to do, since we're not returning science images up here, we're actually returning lists of science images. We're going to go ahead and add that to our return list. It's only going to be it's going to be the only item in there, but that's okay for now. You know, we can modify this later if we need to. We're going to add our new image that we created, and then it returns the images for us. Right? There's the return list. Perfect. This is a DAO. This is a data access object. Its entire purpose in life is to get the data from a source, from like the NASA Astronomy Picture of the Day website, and convert it into a format that our app can use everywhere else, which is our science image, right? Now we're gonna have to modify our main activity and our detail activity a little bit to access and use these this new method, but that's all right. It's not gonna be that bad. What we're gonna do essentially is take the code that we had that we just put inside of our Astronomy Picture of the Day data access object, and we're going to abstract it out here. Let me go ahead and remove that code. That's the code that we just put into the data access object. All this right here. Let's get rid of that. And we're going to go ahead and get rid of these catches on the bottom as well. All right. And I may have to add something here later, but that's not a big deal. So this stuff, the image URL, the image title, all that stuff, we don't need to worry about. We're going to go ahead and grab our Astronomy Picture of the Day DAO. Let's see. One piece that I missed here. We don't want this to be an instance, right? We don't want you to have to create an instance of the APOD DAO. Or do we? Maybe we do. You know what? In this case, we can leave it that way for now, and I'll show you how to convert this into a static later on, and maybe in another show. So let's say APOD DAO APOD equals new APOD DAO. Normally these would be static because they don't change, but if you wanted to pass a URL in here, let's say you had a data access object that you wanted it to be more generic, this would be the pattern. This would be a good pattern to use. We're going to say apod.retrieve. And it's going to return to us a list or an array list of science images, right? We're going to call this images equals apod.retrieve. And we'll go ahead and auto import, Alt Enter, and let me see what else it's mad about. Incompatible types, cast to array list. Perfectly fine. Yep. So we're just adding a cast here. This is just saying go from a list to an array list. So we're doing a specific implementation of it. All right, and then let's see what we actually want from this APOD data now. We're not going to use this. We don't need to do this JSON stuff anymore. Now we can just say images.getZero, which is the first item in the list, .get description, maybe something like that. And now we can say images.getZero.get title. You can see how this already is going to make a big difference, right? We already are making our code much simpler. Let's go ahead and drop in here. Instead of the image URL, we'll say images.getZero.getImage URL, right? And we'll have to put a little try catch around this guy, but that's all right. Not a problem. And then finally at the end, we're going to do a create stream from drawable. I'm just going to wrap everything inside this catch statement. I'm going to do that so that nothing gets in a bad state. If we don't get the images to download properly, I don't want it to die. So I'm going to do it and put the catch all the way around it. My image here equals drawable.create from stream, this input stream. The only other thing we have here is instead of the name being set to the title, we're going to say images.getZero.get type. It's not available. Let's see. You know what? We had it as part of the class here. I can still say, let me see. Yeah, it's because it's not part of this anymore. So what I can do here is I can say maybe I'll have to figure out a way to get this to work. There's a little hitch right there. I'm setting the M image. I guess I can do it here. So M title, or M name, sorry, equals images get 0 get title. Let's see here. No, you know what it is I M name. Okay, yeah, I'm just gonna set this M name equals other than M image. Let's do. Oh, how am I gonna do that? I guess I'll have to put for the description, the title. I'm just gonna have to save that off somewhere else here. Let's go ahead and do. Oh well, I'll have to play with it. I'll have to show you guys that a little bit later. In any case, and we don't need the JSON exception anymore here because we're not using JSON in here anymore, right? Let's go ahead and turn that guy here. And maybe what we'll do is we'll set the, we'll need to find a way to set this up a little bit. That's fine. All right, so that's, here we go. If we put it up on top, if we put the current name of the displayed image up here, it'll probably work. Title equals, yeah, whatever. We get the gist of it, I think. There we go. We have an M title right here. That's what I really wanted, was this M title. So I'm going to go M title right down here. I'm just going to set it equals images.get0.get. Yeah, that's what I want right there. And then we'll set our M name, which is actually the view, the widget, to our title. Still just getting the data from our single instance of the science image, right? So the science image is what's actually doing all the work. That's what we want out of it. Let me just get rid of these guys here. So you can see how all that code that we were using to get the astronomy picture of the day data access object, it's all kind of been decoupled now. We're not doing it in the same place that we're doing the interface anymore. We're not updating, we're not downloading the code or downloading the astronomy picture of the day and then adding it to the image right away or adding it to the UI right away. We're using a separate class that just handles the data. And then we're taking that data inside of our activity here and we're putting it where we want it to go. This is a really good practice. It's called the separation of concerns. And you want to say, take this stuff that does something, take the data section of it and separate it out. Make it completely separate from the rest of my app. Let me see, where's the detail? We're going to look for the place where we actually start the detail activity. So let me see, we're going to do start activity, right? And you can see, actually, I already have those in there. So what I'll do is I'll say the M title and the M description. When I get them from the DAO, from the 8Pod DAO, I'm just going to go ahead and put them right in there. So I already had the title. I'll do M description equals images.get0.get description, right? Because the description is going to come right from there. Do I have any others of these that I want? There's description, name, content. Maybe I want content, perhaps. I want anything else? No, I think I'm all right. Image URL, description, title. That's probably fine. That'll work, I think. So we're going to go back down here to our app, get rid of that. And that's, now what's really cool about this is because the main activity was sending data to the detail activity, we don't have to put the DAO inside of the detail activity. It's getting passed in this data that we downloaded. Let's go ahead and run this guy and see what happens. So we're going to run this. I'll pull up the emulator for you. Let's take a look at this emulator screen. Down. Let's go ahead and run it and see what happens. Load it up and bam. And by the way, this may seem kind of crazy, but we actually completely refactored this app and it still worked. And if we hit the details tab, we still get the description in there because we were always sending it over from our main activity anyway. So now we're just using this astronomy picture of the day data access object to retrieve the data. Now, why is that at all interesting, right? What's the interesting part about this? The cool part is that now, if we want to make another type of data access object, if we want this thing to access data from, let's say, a Hubble data access object, we can create a brand new Hubble DAO, right? Or actually, you know what? Let's find a real data feed. Let me see if I can find one that'll make sense here. I should have maybe picked it up earlier, but that's all right. I don't mind. So we'll say, let's say NASA imagery. And maybe we'll do this next time. Let's say we wanted to show the Lotus Land, what is it, rapid response? Image resources, how about that? They can show the Cassini images, right? We can have it actually show images from, you know, a spacecraft of some kind. As long as we have access to the image, to the API, we can make a new data access object for it. So let's make a new class. We'll call this the Cassini data access object. And as long as it implements our iScienceImage DAO, we're going to be able to do this. Inside of here, we're going to return a list of science images. And now we can just plug it right into our main activity. We can say array list of science images. We'll create a new, instead of just astronomy picture of the day, let's go ahead and create a new Cassini data access object. And we're going to retrieve data from both of these sources, and we're going to combine them into one list. And that's the really cool part, right? That's the beauty of this thing here, is that we can take these two things and combine them into a single list. So we'll say images dot, what is it, concat, I think it is. Whenever you want to combine two, you can combine two array lists together. Let me go ahead and do Cassini dot retrieve. And we'll say images dot, we can do add all, that'll work. So we'll do images dot add all. We're actually going to combine the images we got from Astronomy Picture of the Day with the images we got from Cassini. And we can do that with as many of these as we want. Let's say we had one for Hubble. Create a new one for Hubble. Implements iScience DAO. Or iScience Image DAO. And we're going to implement. And now we can do the same thing with our new Hubble data access object. We'll say images.addAll, Hubble.retrieve. Now that right there should indicate how really cool and amazing this pattern is. Now we've taken data and we've abstracted it out. We can add as many data sources as we want. And it's literally in our application code, it's 2 lines of code to do that. We add it here and then we just append it to this list we already had of images. And it'll work. This will actually show us all the images that we need to see from this thing. So if we had something that showed maybe multiple images, right? We wanted something that collected all of the Astronomy Picture of the Day data and the Cassini data and the Hubble data, we can do that and display it all in one interface. So kind of a cool thing. And just for fun, let's just see what it actually does if I run it. As I know these are returning null, so I'm a little worried, but who knows? Let's try it. I say when in doubt, you know, let's break it and see what happens. All right. Here it comes, and broken. Yeah, I figured that might not work right away, but the gist of it is right. This is the exact pattern that you would want to use to solve a problem like this. Cool. So, you know what? We were going to do fragments today, but as usual, I ran out of time, so I'm going to save our fragment and an activity discussion for next time, but that will be the focus of our next session, will be fragments, how to refactor this Astronomy Picture of the Day app using fragments. Alrighty, so yeah, that's it. Thank you very much for coming. Thank you for participating. Thank you to Kevin and Wayne for being there and, you know, keeping me on task and everything. and I'll see you guys next week. All right, take care and go code your face off.